Welcome to the Hitchhiker's Guide to Calculus. My name's Kevin, and I'll be your guide to Chapter 1.8, Infinite Limits. Here we're going to look at the algebraic side of things. We've got a few limits off to the left and some directions off to the right. We'll talk through those in a moment. Let's start with the limit as x approaches 2 from the left of 2x minus 5 over x minus 2. Our first rule of limits is plug in that value that x is approaching. So in all these cases, we're going to be plugging in 2. All right? And in all these cases, we're going to get the same result because it's the same function. But certainly when we plug in 2, we're going to get 4 minus 5 over 2 minus 2, so negative 1 over 0. All right? Now this is important to note. This is definitely undefined. Dividing by 0 is no good. So anytime we evaluate a limit and we get some value over 0, or that numerator isn't 0, the 0 over 0 case is special. So when we get any other number in the numerator, we know we have a vertical asymptote, which means our limit can really only go two ways. It could go down that vertical asymptote, or it could go up that vertical asymptote. Right? And that's what our job is to check. So how do we check? What we do is we test a value on the appropriate side of the value that x is approaching. So since we're approaching 2, and in this first example we're approaching 2 from the left, we're going to pick a value of x that is slightly less than 2. Now this is one of the only situations where we don't want to plug in 2. We can't plug in 2 because we know that's going to make our function undefined. So we're going to test 1.9. We plug in 1.9 into the numerator and the denominator, evaluate this, and we really only care whether our answer is positive or negative because we know our function has to be going up or down to positive or negative infinity. Right? We evaluate this and we see that we are going to end up definitely with a positive number. I don't even actually care what the value is. I just care that it's positive. Right? If we do this same game with our second example, we're still going to get negative 1 over 0. We know there's a vertical asymptote, so we're going to test a value that's a little bit to the right of 2. So let's try testing 2.1. Right? Again, we plug it into our function. Again, with the only goal of telling whether this quantity is going to be positive or negative. Right? We evaluate this. It looks like the numerator should be 4.2 minus 5, so negative 0.8, I think, divided by 0.1. And that's a negative divided by a positive. So overall, this should be a negative value. This tells us where each of these limits is going to go. Because we know it's an asymptote, I know my function has to go up to positive infinity, down to negative infinity, or it could not exist. So since our first example we ended with a positive, I know the limit as x approaches 2 from the left of this function has to be positive infinity. In the second example, since we learned from our test point that we end up with a negative value when we're close to 2 but a little bit to the right of it, we know this limit, this function, is going to approach negative infinity. Right. And lastly, we can answer the limit as x approaches 2 of the entire function, but this is really a conclusion based on the previous two questions, and since they don't agree with each other, the overall limit must not exist. I hope this video provided some insight, but if you have any questions, don't forget to check out the link below for a free lesson with one of our expert tutors. To see more videos like this, click subscribe. Or to continue your journey through calculus, click the next video on your left.